All right, next up we have Aspen from Jane Street. Close enough. Backward. Yeah.
Can it only go forward?
Backward, I think.
I need a down arrow. I'll just use the keyboard. Slides are weird. Cool. I'm gonna try to keep the lightning and lightning talk. So there's a lot to talk about here, but this is a very whirlwind tour of some very ad hoc infrastructure I built at Jane Street to do distributed Nix builds. Jane Street started adopting Nix last year, early 2024. We're kind of have historically been an RPM shop and wanted to sort of decouple from the versioning strategy of RPMs and decouple from the enterprise Linux release schedule and allow, sort of more flexible package management, per binary package management. So we're not using Nix as a build automation tool, really just as a package manager. So just for system level packages and open source Python packages. We had a problem with this, which is that we want a really strong security model for Nix builds. We care a lot about security. We want package signing. We want limited access to the signing keys. We don't want to give people access to the root signing keys for packages. But we also want to let people build and distribute Nix packages, sort of anybody at the firm. We want them to be able to build something and then have it available everywhere. Now, you can do this on a single machine pretty well. If you sort of expose force command in your SSH daemon and then expose that server as a SSH-ng store, you can sort of allow a user to trigger a remote build on a single machine and then have a post-build hook that uploads that to a binary cache. But we have a bunch of machines, right? We have a lot of computers, and we regularly do full rebootstraps of Nix packages because we're not depending on cache.nixos.org. So we want to be able to distribute builds and sort of load balance builds across our pool of builders. This is kind of like not something that the Nix remote builds infrastructure supports natively. So I built a thing called JS Nix build, and it's a bit of a hack, but it's a fun hack. The JS stands for Jane Street, not JavaScript. We prefix everything with JS because big companies do this. And JS Nix build is kind of the simplest thing that could possibly work. It's just, the general idea is you take all of the builders that you have, a big pool of builders, put them in a circular list and put them in random order. And then recursively for each derivation, you Nix derivation show it. You ask if the store path of the outputs is valid in the cache, in the centralized binary cache. If so, you short circuit. Otherwise, you look at all of its input derivations and recurs on all of them. And then once all of the input derivations are built, you build the derivation you're currently building on the next builder in the list. And then you're maintaining some terminal progress bar thing. So it's like a total hack. You're shelling out to Nix derivation show. You're shelling out to Nix build -- store. You have this list of builders that's statically configured. In order to make this work, of course, we need a central binary cache. We're a big organization. We have our own data centers. This is kind of just a thing that we have. You need a post-build hook that uploads to the binary cache. If any of you have worked with post-build hooks, getting that to work consistently and reliably is a bit of a thing, but we were able to get this working. And it works really well, actually. I'm surprised at how well this works. It was a hack that I put together in a week. So initially this was meant as a proof of concept, right? It's we need to build stuff with Nix. Let's build a quick build scheduler. But it's kind of worked unchanged more or less for the last year. It's the main thing that we use to build Nix packages. We haven't really needed to make it scale. We started out with 8 builders and we haven't really scaled past 8 builders. We're regularly rebootstrapping Nix packages, but that's a couple of hours, which isn't that bad. The only significant change we made was to switch from a random round robin scheduling to hash-based scheduling so that if 2 people build exactly the same store path, they don't redo the build. Which was a pretty nice change. I can't take credit for it, but it was a pretty good change. And the point of this talk, right, the raison d'etre of why I'm up here telling you about this is both to be look at this cool hack that I built, but also to be we should probably have something like this for Nix, right? We should probably have distributed builds with good security, please. I would like to build this. I would like somebody to build this. I wish I had time to build this. Distributed Nix builds kind of suck in the sort of the world out there, right? Networks are slow and bad, especially if you're, not near a CDN. Build hardware is like really heterogeneous. Like when I'm running Nix, personally, I have like my desktop that I'm triggering builds on that has a ton of cores, and my laptop that I might want to run builds locally on, but there's more than just the number of CPUs to pick build hardware. And the distributed build scheduler just like is totally not network aware. It's like, it has this wonderful habit of, building some very cheap, uploading a ton of sources to the remote builder, building a very cheap thing, and then spending forever downloading it, which is really annoying, and I really wish the build scheduler knew how to deal with that. And that's it, that's the end of the talk, because it's only 5 minutes, but we should build that. We should make it better.